Hello students, let us perform experiment low pass filter. Aim of this experiment is to construct low pass filter, and after that we will have to study its frequency response. So first step is design of low pass filter. To design low pass filter we require two components. The first component, that is capacitor, and second one, that is resistor. So here you can see capacitor and resistor. To study the frequency response, first of all we have to find out the cutoff frequency. In the expression of cutoff frequency, we will have to put down the values of resistor and capacitor. For that we have to note down the values of resistor and capacitor. So note down the value of capacitor. Here you can see one code is written on the capacitor, that is 103. So this is the code, and by using this code you will have to evaluate the value of capacitor in terms of Faraday. Then resistor, we have to find out the value of resistor. Here you can see the color combination. First one, that is orange, second one, that is white, and third one, that is red. So using this color code, evaluate the value of resistor and substitute this value in the expression of frequency and find out cutoff frequency. Hello students, let us design a circuit of passive low pass filter. It requires apparatus, resistor, capacitor, frequency generator, digital multimeter, breadboard, and connecting wires. Look at the circuit diagram of low pass filter. It consists of E, which is signal generator, VI input voltmeter, R is resistor, C is capacitor, and VO, which is output voltmeter. These two voltmeter are AC voltmeter because our circuit is AC circuit. So here I have connected the circuit using these apparatus. This one is function generator, input voltmeter. This is the breadboard on which we have connected two components, resistor and capacitor. See the connection. And this one is output voltmeter, which is digital multimeter. So here you can see the connection. This is the wire which goes through the input voltmeter. This is the another wire of signal generator which is connected to input voltmeter, so that input voltmeter is parallel to the signal generator. After that, one wire, see the circuit diagram, one wire which is from signal generator, it is connected to resistor. So this is that wire, this is the signal generator, and that wire through voltmeter which is connected to resistor. Okay, then another wire from signal generator which goes through the another terminal of the capacitor. Here you can see. Then resistor and capacitor, one terminal is connected, and this is the output voltmeter which is parallel across the capacitor. So in this way we can connect the circuit. Okay, so let us start this circuit. So using this button we can start the circuit. Okay, so here you can see the display which shows us the frequency. Okay, so we can change the frequency. I hope you can now handle the signal generator because you have performed the experiment LCR where a signal generator has been used. Right, so here you can see the range. Okay, so this knob is used to change the range of frequency. Okay, and within that range, smooth variation which is given by using this knob. Okay, so here you can say that this is the 100 multiplied by, this sign is multiplication side by 100, that means you can see the variation from in the range of 100. Okay, after that, suppose you want to set the frequency in the range of 1k. 1k means, here you can say multiplied by 1k. It means this is the range where we can vary the frequency in the range of 1000. Then after that, multiplied by 10k. Okay, so in this way we can vary the frequency by using these two knobs. Then one knob is present at here. This knob is amplitude control. Amplitude means amplitude is related to voltage. So actually we are providing the electrical signal. This signal generator is used to provide the electrical signal. Various shapes are there. Here you can see square wave, triangular wave and sine wave. So here I have set this at sine wave. Okay, so amplitude of that sine wave we can change. That means amplitude means voltage. Okay, so here by using this knob we can change the voltage. You can see it here. In this way we can change the voltage. So I have to keep this voltage knob fixed. So I have selected 4 volt. So throughout the experiment, input voltage which must be constant. So input voltage Vi, which is shown in the input voltmeter, which is 4 volt, and throughout the experiment this voltage is constant. Okay, then we have to in which way we have to perform the experiment. It is shown in this chart. Okay, we have to vary the frequency starting from 100 and log of f, which is the calculation part, and we have to note down the output voltage. Okay, so this one is output voltmeter. So first of all we have to on this. Here you can see. Okay, so here you can see this is the pointer, and now the pointer is in AC range. Okay, VAC. When pointer is at this position, then we can measure the AC voltage. Okay, so let us start this experiment. First of all we have to set the frequency 100. Okay, so let us set it. So now range is 100. Okay, now I have to set it 100. Okay, now 96 is there. Smoothly we have to go. Okay, so it is 100. Now input voltage is 4 volt. If it varies, then we have to make it 4 volt by using this knob. Okay, now input voltage is 4 volt. Then note down the voltage for 100 hertz frequency. So it is fluctuating. You can consider the maximum value or average value. So just write down 3.8. Right? So for 100 hertz, you have to write down at here 3.8 output voltage. Okay, now we have to set for 200. So how to set? Range is 100. Okay, that means we have to change this knob. Okay, now 200. Note down this one. It is fluctuating. You can write 3.8 as it is, or 3.7 you can also write. Any value you can note down since it is fluctuating. Okay, then 300. So just I am setting this value. You just note down the voltage. I am not repeating the part again and again, because now you have to just note down the voltage at various frequency. Okay, 300. Then again same 3.8. Let us go for 400. Okay, then 3.7 I think. $500. Note down the voltage. 3.7. Then 600. Okay. Again voltage is fluctuating. The minimum value is 3.4. You can write this reading as a 3.6. This is for 700. Again write down 3.6 for 700. Okay. This is for 800. .5 you can write. $900. You can write 3.5 or 3.4 also. Any reading you can take. Then I am setting for 1000. So this is for 1000. Reading is 3.4. Then for 2000. Okay, so I can take reading up to 1000 in this range. Okay, and suppose I want to take the reading above 1000, then I have to change the range. Now range is at this position multiplied by 1k. Okay, so 1000 reading that we have already taken. Let us go for 2000. Okay, this is 2000. 2 multiplied by this one. For 2000, there is a change in the reading. 2.9 you can take. Then let us take 2500. Again 2.5. And 3000. For 3000, 2 point. See this reading. Now for 4000. $1.9, 5000, 1.6 or 5, 6000, 1.4 or 1.3. As I said, the reading is fluctuating. You can take any reading. But suppose you have noted maximum reading, then note down maximum reading every time. Suppose you are noting down the average reading, then note down average reading. Suppose you are noting the minimum reading, then note down minimum reading among those reading which are displaying continuously. 1.2. Okay, let us take 1.2. Then for 800, not 800, 8000. 1 or 0.9. So let us take reading, because reading is approaches to 0. So let us take 2 more reading for 9000 and for 10,000, and after that our observation is over. For 9,000, 0.7. Okay. For 10,000, this is our last one. Okay, 10,000. Okay. 0.6 can write. Okay, so in this way we have to note down the output voltage by varying the frequency. Okay, so this is our observation part, which is over.